The image on the shroud is sometimes very hard to see. It just seems to be almost blurry.
That the Shroud of Turin, which again is currently in Italy, we believe it to be the very burial cloths of Jesus of Nazareth.
For more than a century, the Shroud of Turin has defied microscopes, X-rays, and skeptics. Now, AI has cracked patterns in the linen that shouldn't exist. Radiation signatures, 3D depth rules, and mathematical ratios woven into the fibers. Are we staring at a map of an energy event no lab can reproduce? Did the cloth measure a body in space? And why does the image ignore blood, yet form around it with impossible precision? We'll trace the mystery from the first photos to AI decoding and what it means for science and belief.
The leader of the Roman Catholic Church, Pope Francis, prays before a 14-foot-long ancient linen cloth.
The cloth that shouldn't be. It begins with linen, plain, ancient, and impossibly stubborn. Nearly 14 feet long and a little over 3 feet wide, the Shroud of Turin looks, at first glance, like a relic stained by time. Yet on its surface lies a faint, full-length imprint of a man, front and back, bearing wounds that echo a Roman execution. Wrist piercings, scourge marks, a pierced side, and what appears to be punctures from a crown of thorns. This is not a painting in any normal sense. Under magnification, there is no brush stroke, no pigment layer, no binder. The image does not soak into the threads as a dye would. Instead, it grazes the outermost fibrils, mere micrometers deep, like a breath that singed the tiniest tips of the fibers and stopped. That one simple fact has confounded generations. An image so clear, formed so shallowly, with no known medium. The blood tells a second, stranger story. Where crimson stains darken the weave, the cloth behaves like any linen would. The fluid has penetrated the threads and clung to them. But the body image is different. It sits on the surface, never disturbing the blood, as if whatever formed the image happened later and with exquisite restraint. Scientists who expected to find pigment found none. Those who expected to see directionality, like heat from one side or a rubbing from contact, found no consistent push or pressure pattern. The image is non-directional, shallow, and precise, as if it recorded proximity rather than touch. That is not how forgeries behave. That is not how paintings behave. That is not how heat-scored cloth behaves. For centuries, access to the Shroud of Turin has been very limited. The famous relic is kept in a custom-made case, monitored with glass, inert gas, and a considerable amount of caution. The labs have mainly been provided with tiny samples, the edges or repair areas of the shroud, mostly threads. This limited supply not only irritates the scholars, but at the same time underlines the unique status of the cloth. No other sample, no additional shroud for testing and experimenting without restrictions. Each test must be conducted prudently. Each conclusion is very much questioned. Throughout the years, scientists have tried to recreate the picture using acids, powders, contact transfers, scorching, vapor reactions, and even light flashes. All these methods can mimic a part of the effect. Here a little color, there a bit of superficial depth, but none can recreate the shroud's triad: extremely fine surface modification, non-directional shading, and the absolute separation between image and blood. The more you push a technique into one characteristic, the more it slays the other ones. The provenance threads are another source of discomfort. The pollen that is encased in fibers involves species that are related to the Levant. The weave, a herringbone pattern, is identical to the one used in first-century textiles and thus corresponds with the ancient methods, although such weaves have also been found in later times. The fibers differ in age and condition, which is what you would expect from a cloth that was revered, handled a lot, repaired, and subjected to a lot of disasters, the most notorious being a fire in 1532 that burnt and patched the linen with quite recognizable burns and triangular water stains. The critics refer to the well-known radiocarbon tests conducted in 1988, which dated a sample to the Middle Ages. The proponents retort that the corner that was tested possessed chemical and textile anomalies, perhaps indicative of repairs that could lead to an inaccurate date. However, both parties agree on one common point. The physics of the image remains a mystery. Even the people who are absolutely sure that it is medieval find it hard to come up with a credible methodology that would yield the shroud's microscopic signature. If classic methods failed, the first shock arrived when a camera, not a scalpel, made the cloth speak, the negative that spoke first. It was 1898 when a lawyer and amateur photographer named Secondo Pia entered the dimly lit cathedral in Turin to photograph the mysterious relic that had fascinated and divided believers for centuries. He expected nothing unusual, just a documentary image of a famous artifact. But when he developed his glass plates in the darkroom, what stared back at him stopped his heart. The faint, almost invisible image on the cloth had transformed into a clear, lifelike face on the photographic negative. It wasn't a shadow or stain, it was a portrait. A man's countenance with striking definition, eyes closed, lips relaxed, and features that seemed sculpted in light. Pia thought it was a mistake, but the image was real. The Shroud of Turin behaved as if it had been designed to be developed like a photograph centuries before cameras even existed. The discovery had a great impact on Europe. Newspapers even had a picture of Jesus on the front page. Doubters called Pia a liar, but when later the same photographs were taken under the same conditions, the phenomenon recurred over and over. The cloth was like a photographic negative. Light parts turned to black, and black parts turned to white. By reversing it, one could see the incredible realism. This was a strong indication of the shroud's mystery, of how the image came to be through a process that imprinted optical depth, one that was already beyond the comprehension of the medieval craftsman. No dye, no paint, no brushwork, just a modern camera baptized with a reversed camera. The image unveiled its full strength. During the early 1900s, a number of scientists flocked to Turin to study the shroud. Their investigation was quite comprehensive, for they looked at the shroud with the aid of microscopes and chemical analyses, trying to trace any painting done or burnt places, or contact prints left behind. However, none of their findings were consistent with the theory of the shroud being a work of art. The chemical analysis of the fibers showed that they contained no pigment or binding medium. Also, when subjected to ultraviolet light, the image was found to behave in a manner entirely opposite to what was considered typical of painters. Rather than the paints auxiliaritits absorbing light, it was reflecting through some post-parasitic modifications of the cotton's cell walls. Thus, in this way, scientists reached the conclusion that the coloration was not applied, but somehow embedded within the molecular structure of the outer layers of the linen. All the fibers' surfaces looked very slightly oxidized, as if they had been given a very brief pulse of energy, which changed just the very tips of the fibers while leaving everything else unaltered. More questions stacked one upon the other. How come the picture did not lose its proportion even when it was spread over a three-dimensional object? Why was there no distortion at all, even in areas where the fabric touch should have stretched or distorted the details? And how could bloodstains be underneath the image layer, not affected by it, as if the image appeared through an unknown, non-contact process? Imaging experts in the early days put forward several theories: vapors from decomposition, chemical reactions from burial ointments, even flashes of early photography by accident of nature, but none could replicate the entire effect. The negative characteristic of the shroud was still extremely unique. Enter machines that see what we miss. AI doesn't believe, it measures. Machines that see the hidden. By the time the 21st century arrived, the Shroud of Turin had been examined by nearly every tool science could offer: spectroscopy, X-ray fluorescence, infrared imaging, and electron microscopy. Each test revealed another layer of impossibility, yet none could explain how the image formed. Then came a new kind of investigator, one that didn't need belief or bias: artificial intelligence. Researchers realized that if any system could detect hidden patterns invisible to the human eye, it was machine learning. They fed thousands of high-resolution scans of the shroud into advanced neural networks, allowing algorithms to do what decades of traditional science could not: see everything, all at once. The first thing AI did was strip the image down to its essential data. Using a method called principal component analysis, the system isolated what it called the dominant signal in the image, the pattern that contained nearly all the meaningful information. To the researchers' astonishment, 98% of the data existed within one component: the brightness differences across the image. That meant the entire shroud's mystery could be expressed as a single, coherent relationship between light and dark. Paintings, photographs, and even random textures never behave that way. Their information spreads across multiple dimensions of color, tone, and shape. But the shroud's image was astonishingly efficient, as though it had been generated by a single mathematical rule rather than by accident, artistry, or time. Then, the AI also looked at the physical positions of each pixel under the cloth and simultaneously made a comparison between the intensity of the respective pixels. This caused complete astonishment to the team. It turned out that the brighter parts of the image corresponded to the points next to the fabric. This was not conjecture. It was a measurable and consistent correlation that was maintained all over the cloth. The machine discovered no randomness, no artistic brush variation, no pressure distortion, just a perfect physical gradient. The shroud appeared to follow a distance law, converting space into light with the accuracy of a laser scanner. Whatever had produced the image had not only marked a surface, but also inscribed geometry. The AI was not finished working yet. Researchers feeding it with ultraviolet and infrared photographs of the same areas found out that the mathematical correlation between brightness and distance was still the same for all wavelengths. It meant that the same principle was applied whether the machine examined visible light, UV reflections, or heat signatures. The pattern went beyond light itself. No color, dye, or heating element could act in such a way. Typically, pigments have different reactions under UV or IR scans, exposing the presence of minerals, carbon, or heat damage. Yet the image of the shroud showed none of these irregularities. It was as if the image had been imprinted onto the cloth by a type of energy that acted the same across all the spectra known to physics, even the most obscure ones. The AI subsequently focused on the image's traits, small variations in brightness, arrangement, and symmetry. Its discovery was so astonishing that it caused a tremor in the lab. The variance of light and shadow had a rule, and every part was obeying a soft mathematical ratio, where there was a perfect geometric relationship repeating among the main features: the face, the hands, the trunk, and the legs. The ratios were the same as those of human anatomy and classical proportions, but they were more like the fibers directly coded than drawn. The computer tested random samples from medieval art and declared it found nothing like that. Even the modern digital recreations were not able to reach the same structural harmony on both macro and micro scales. If brightness matches distance, then the shroud isn't an image, it's a 3D record. Can we prove that? Geometry in linen, the 3D code. When the first image analysts in the 1970s fed a photograph of the Shroud of Turin into a NASA VP-8 image analyzer, a machine originally designed to convert flat photographs of the moon's surface into 3D relief maps, they expected nothing. Ordinary photos, when run through the VP-8, distort wildly. Noses stretch, limbs twist, and shadows collapse into chaos. But the moment the shroud's image appeared on the screen, scientists froze. The figure rose out of the darkness as a perfect three-dimensional form. Every contour, the nose, the chest, the arms, displayed correct spatial depth, as if the image had been created by measuring the distance between cloth and body. No painting, photograph, or engraving could replicate it. What they had thought was a flat stain suddenly behaved like a sculpted hologram. That discovery, confirmed by multiple labs, redefined the shroud as something far stranger than a medieval curiosity. It wasn't an illustration of a body, it was a map of one. The intensity of the image corresponded directly to how close each part of the body would have been to the linen. The VP8 data showed that even minute shifts in brightness aligned perfectly with natural anatomical relief. Where the body would have pressed more closely, nose, forehead, and chest, the image was darker. Where fabric would have hung slightly away, cheeks, sides, and lower legs, the image was lighter. The shroud had somehow encoded distance as density, turning space into tone. Later, the artificial intelligence confirmed and broadened the finding. I got to the conclusion that the distance-to-brightness correlation was not just a phenomenon of the macrocosm, it was also true in the microcosm. The minutest fibers had shading differences that were consistent with their distance from the surface of the three-dimensional object. Thus, the whole piece of cloth acted as a pixel in a huge, ancient depth map. When the image of the shroud was digitally reconstructed, it created a perfect 3D model of a human figure, well-shaped, well-balanced, and exact by the numbers. It was not a picture of a man. It was a photographic representation of the space. The concealed mathematical patterns hidden in that space were even more unsettling. AI methodologies recognized 1 to 1.618 parallels, the relationship between facial features, torso length, and the position of limbs across certain of the most important areas of the image. The numbers were reflecting, in a way, the so-called golden ratio, a mathematical constant that is found in nature, architecture, and classical art. But in the shroud, these ratios were not artistically created, but rather encoded automatically. Every curve and contour adhered to geometrical laws with no exceptions, as if the whole process of formation was under the control of a natural algorithm. There was no known physical process, whether chemical, thermal, or photographic, that could accidentally create such consistent geometry. The microscopic examination revealed even more unexpected things. The coloration on every single fiber was measured to be merely a few hundred nanometers deep, which equals approximately 1/50 the diameter of a human hair, and it was happening only on the outermost fibrils, never going into the interior. It was like an ultra-precise burst of energy had just barely touched the surface of the cloth, thus changing its top molecules without going any deeper. The same three-dimensional pattern was observed under ultraviolet and infrared imaging, which indicated that the energy had interacted with the cloth in several light spectrums at one moment. The image was not a layer sitting on top of the linen, but rather a structural change within it, like data being imprinted on an organic medium. A 3D map without pigment begs a brutal question. What formed it? The answer points to energy, the radiation hypothesis. Once AI had proven that the of Turin encoded three-dimensional spatial data in its fibers, one haunting question refused to fade. What kind of force could have created it? Every experiment pointed to a burst of energy, instantaneous, intense, and unimaginably precise. The image behaved like the aftermath of radiation, but not the destructive kind that burns or scars. This was something different. A brief flash that altered only the outer molecules of the linen without scorching or penetrating deeper. Scientists began to suspect that the key to the shroud's impossible geometry lay in an event of light and energy, not pigment or pressure. The radiation hypothesis had existed for decades, dismissed by many as pseudoscience. But after the AI results, it was the only explanation that could fit the data. The image's surface-level depth, no more than 200 nanometers into each fiber, matched what one would expect from a burst of ultraviolet or particle radiation lasting microseconds. Too weak to burn, too short to spread, yet powerful enough to oxidize cellulose molecules and cause the faint golden color that forms the body's outline. The energy would have had to emanate not from outside the cloth, as a lamp or flame would, but from the inside out, radiating evenly from a central source, exactly as the three-dimensional mapping suggested. For this purpose, The scientists took linen samples, wrapped them around various things, and applied radiation of different types to them: ultraviolet lasers, ion beams, corona discharges, plasma bursts, and electron emissions. Each experiment showed some similarities only in their partiality. The UV lasers were able to reproduce the color tone, but their penetration was too deep. The corona discharges made very small marks, but the resolution was not good. None of the methods could get the combination of the shroud's microscopic precision, 3D geometry, and uniform coloration. The best modern tools were also not able to match the mathematical relationships that the AI had discovered. Whatever made the shroud's image, it had achieved an energy control that no human technology, ancient or modern, has ever surpassed. The disturbing detail was, however, the very limitation to which this energy must have been localized. If it were to come from a complete human body, the bursting would have influenced the materials around it. But the linen itself is the only place where there is no trace of such radiation. The phenomenon seemed contained, specifically directed to the fabric, and without the air or environment around it being modified. This impossible containment made scientists feel uneasy. One physicist characterized it as a light that acted as if it were aware of where to stop. How could energy be so restrained in its action? Some scientists sought solutions in the realm of theoretical physics. A natural occurrence, possibly of chemical corona discharge due to body fluids or environmental factors, could still explain it. Not really. The pattern was just too consistent. An unidentified plasma reaction or quantum effect? No proof was found. The only result that was agreed upon by all was that the image had been produced through a controlled and well-timed radiation burst. The energy came so fast and precisely that it matched the body's contours. Each fiber recorded its distance from the energy source, leading to its brightness representation. It was not random exposure, but measurement, an encoding event of exquisite order. This, in turn, opened up even more profound questions. If a burst of radiation could imprint three-dimensional data onto cloth, what was the source of that burst? Some thought it could be electrical, an electrostatic discharge from decaying organic matter, though the required energy level made that implausible. Others said a burst of particle radiation, like what happens in solar flares or high-energy physics experiments. But those phenomena produce chaotic effects, not the symmetrical precision seen in the shroud. The pattern did not seem to be destructive. It rather presented itself as creation, as if energy had come from nowhere, stretched out, and disappeared all at once, thus presenting a flawless map of its course. If the physics is that exact, why can't the world's best labs reproduce it? Watch the scientific shockwave. The carbon clock and counterpunch. For decades, the Shroud of Turin's greatest controversy has revolved around one scientific test, a single measurement that was supposed to end every debate but instead divided the scientific world. In 1988, researchers performed a radiocarbon dating test using tiny samples clipped from the cloth's outer edge. The result was clear, or so it seemed. 3 laboratories in Oxford, Zurich, and Arizona reported that the linen fibers dated between 1260 and 1390 AD, placing the shroud firmly in the medieval period. Headlines exploded around the world. Medieval forgery, they declared. To many, the mystery was solved. But inside the labs themselves, doubts began to grow almost immediately. The numbers didn't add up, not chemically, not physically, and not visually. One of the scientists involved later admitted that something felt wrong. The fibers didn't look like the rest of the cloth. They were unusually fine, unusually bright, and under the microscope, mixed with cotton, a material absent in the rest of the shroud's linen. At first, this was brushed aside until textile experts examined the samples and discovered clear evidence of reweaving. The section chosen for testing wasn't part of the original fabric. It came from a corner that had been repaired after the 1532 fire, where the shroud had been scorched and patched with newer material. The medieval threads, it turned out, were from a restoration zone. The radiocarbon clock hadn't measured the age of the ancient cloth. It had measured the age of its repairs. This revelation sparked the debate once again after many years. The chemists examined the fiber coverings and noticed differences that were impossible to overlook. The sample taken from the corner had the dyes and organic materials, most probably from the repairs done in the 16th century, that were not detected anywhere else on the cloth. The situation was made even worse by the discovery of minute cotton fibers that had been meticulously infused along with the linen, indicating that the main fabric had indeed been partially rewoven with new and original threads forming a nearly imperceptible patch. If proved, this would imply not only that the 1988 dating was wrong, but also that it was scientifically invalid. The clock had been set on the wrong fibers completely. In the meantime, other pieces of evidence were still questioning the medieval conclusion. Pollen grains that were encased in the linen came from plants that were only found in the Middle East, species that were native to the area around Jerusalem and were absent in Europe during the Middle Ages. The soil particles that were discovered near the foot area had the same composition as the limestone that is unique to the region around Golgotha. The weave pattern, which was a very intricate herringbone design, was more characteristic of the ancient textile techniques that were unearthed in 1st century Judea. None of these discoveries alone was sufficient to determine the cloth's age, but collectively they constructed a scenario that was inconsistent with the medieval account. The more thoroughly the scientists investigated the shroud, the more they found it difficult to disregard it as a clever impersonation. And then the blood appeared. The analyses backed by AI specifically verified that the reddish spots were not paint or coloring. They were real blood, with human hemoglobin and serum separation being among the factors of the blood flow in the corpse that marked the time of death. The image and the blood stains that had once been thought to be part of the same process were now conclusively proven to be separate phenomena. The blood was the first to penetrate the fibers, and the body image, by some means, formed around the blood without disturbing it. This sequence ruled out all theories that the image was painted or transferred through contact with a corpse. The body image was created after the blood had already dried, an effect that is impossible to achieve through any known artistic or natural process. AI's verdict doesn't settle faith, but it forces science to rethink what's physically possible. Shock to the system. When the final AI analysis of the Shroud of Turin was released, the scientific community fell into stunned silence. For centuries, every new theory had promised to close the case. But artificial intelligence had done something no human mind ever could. It had processed millions of microscopic data points, stripped away centuries of damage, and revealed patterns hidden deep in the weave. What it found was undeniable. The image wasn't random, artistic, or accidental. It was structured information, the physical record of an energy event that encoded geometry, proportion, and spatial distance at a level of precision that no medieval craftsman or even modern laboratory could replicate. The result forced even skeptics to reconsider everything they thought they knew about physics, history, and human capability. Verification of the results was a contest among the teams from Europe and North America. The experts from the different fields of optics, radiation physics, and materials science operating the AI had already proved it. They found that the correlation of brightness and distance measured in the shroud's image was perfectly color-reflecting, as an artist had used light obeying the mathematical law. The spectral data told the story of a discharge of electromagnetic radiation rather than a chemical stain. Also, the fibers were found to possess the chemical fingerprints of a process that had only transformed their exterior, oxidizing the cellulose molecules at a nanometer depth, while the centers remained unchanged. This effect could occur only under one condition: a perfectly synchronized energy event lasting less than a millisecond. What initially seemed like an intriguing mystery turned out to be a real headache for the scientists. The amount of energy that was necessary for such an even distribution of molecular changes was enormously high, almost equivalent to that of a nuclear blast. However, the whole process was different in that it did not produce heat or destruction, which is normally associated with radiation. One scientist even said it was a paradox of light, meaning that it was like radiation in a way, but at the same time, it showed intelligence of design, as if it knew the precise extent to which it could go and when it should stop. No one could find a physical process that behaved in such a manner. Attempts to recreate the Shroud's image with lasers, plasma discharges, and ultraviolet light were only partially successful, too deep, too uneven, or too chaotic. Nothing came close to the precision measured by AI. Such a failure had the disturbing implication that the former event, which created the image, might have been a non-destructive energy conversion event where matter turned itself into energy with perfect symmetry. In this regard, the Shroud would be the trace of that transformation, the quantifiable echo of a process that science cannot yet define. The religious scholars would find it hard to believe that such an event could happen 2,000 years ago in a tomb, as it would not be a supernatural but a superphysical interaction of matter and energy, which is beyond our current understanding. For physicists, it was equally unnerving. They would have to consider that there might be natural phenomena, still obscured, still unexplainable, that can change matter at a molecular level with unimaginable precision. If AI has uncovered radiation patterns, distance-encoded geometry, and multispectral order in the Shroud of Turin, then the mystery is no longer a legend, it's data. Do you think these points point to an unknown natural event, a lost technology, or something even more profound? Like, comment, and subscribe, and watch the next video on your screen for more deep dives into history's most unsettling breakthroughs.